To be in that second webinar of the capacity management framework that we started last time a couple of weeks ago. Today we're gonna drill deeper into one of the first steps of that framework. So let me start by sharing my screen so that we use some visual helpers. All right, so let me share my screen here. I hope everyone can see my screen now. Can you, Jahid? Can you confirm that you can see my screen?
Yep.
All right, cool. All right. As I said, I'm really excited to share the second part of that series of Kubernetes capacity management framework. And today we're gonna talk a bit about how to select the right matrix and build productive dashboards that would help you to manage your capacity. Just a quick note: today's webinar is generic, that it doesn't have to be applied only to Kubernetes. I may use microservices and pods interchangeably, or containers also. But most of the time I'm going to talk about just microservices, and just have this in your mind that microservice is equal to a pod or a container. And that framework in general, I learned it throughout my experience at AWS and Microsoft. Just quickly about me, as I implied, I worked at Microsoft, specifically at Azure. I shipped a couple of products. I worked also at AWS EC2. I had the great opportunity to see how such massive infrastructure works. And then I moved into Climate Corp, which is a successful startup company that's been running on the cloud since the beginning. Was the director of engineering for infrastructure and big data systems. I got my PhD from UConn in performance engineering, and I had a few certs and studies at Stanford as well. So that this is just quickly about me. Just to give you the big picture and where we are today, from those other webinars, we started a couple of weeks ago. That series, and we started by setting up the framework, the 5 steps to better capacity management on Kubernetes. And today we're gonna, as I mentioned, we're gonna drill deeper into that. The next 2 webinars are going to also follow the same pattern, which is basically talking about steps 3, 4, and 5 of that framework that we mentioned last time. If you haven't watched the first webinar, you can go to our website under resources and webinars and see the recording of that first webinar. So today we're gonna focus on matrix and productive dashboards. Okay, cool. So our agenda today, I'm gonna just provide a reminder or a summary of last time, go through how you should be planning your matrix and dashboards. Maybe we'll touch on some common mistakes, and of course I'm gonna also share with you how we're gonna move forward with the remaining webinars in that series. All right, cool. So recap from part 1. Last time we talked about why capacity management is really important. And I quickly mentioned that it impacts user experience, team's productivity, and of course the business viability. And we talked that, or we mentioned that capacity management is all about balancing 3 main factors: resources, performance, and costs of your infrastructure. So you need to find that right balance. And then I walked you through the 5 steps of Kubernetes capacity management framework, which we have, an illustration of it here. You usually start with the right matrix, the right dashboards, adjust your pods resources, make sure after that you have the right allocatable capacity with the right nodes pools, and then you can, from that step, optimize your build, and then you repeat. And we also talked about the common mistakes that you should avoid as you get into that framework in general. So that was about part 1. So today we're going to focus on step 1 and step 2. This is basically what we're going to focus on. And that part has a lot actually to cover, and we would not be able to cover that even step 1. If I just focus on step 1, it would take hours to talk about what's possible there and what we can do. So today I'm just going to provide you some hints and some tips and tricks that you can use in general to have the proper framework with the proper way of thinking about step 1 and 2 of that framework. All right, so it's all about creating an end-to-end plan for you to have the right chain of metrics and dashboards. The whole idea of today's webinar is how can I start with the user experience or the KPIs and go all the way down to the resources that my microservices or pods or containers would use. And once you get that link and you know or understand what kind of resources you have and the patterns that your microservices will have based on the user KPIs and user behavior on your system, you'll be able to follow, move on to the next step, which is allocating the right resources in terms of CPU and memory limits and requests and the right nodes and so on. All right, so today is all about following those 4 steps to build that plan. You should start with the user experience, as I mentioned, map that user experience or the KPI that you have in mind to microservices, SLOs, or service level agreements or objectives, and then map those SLOs to resources. And then at the end, we're going to try to characterize the resources usage or the pattern. And it's just a hierarchical kind of structure that you build over time. At the very top, the user experience or the KPIs, or at the bottom is basically what is the tendency of your microservices to use certain types of resources with that workload. That's the whole idea of today's webinar. It's the generic framework that you can use whether you're running on top of Kubernetes or just running microservices on top of VMs without using any kind of containerized framework or workloads. Okay, cool. The whole topic, just a quick note, a whole topic of building matrix and dashboard is complex, and you can get, as I mentioned in the beginning, it can take hours and hours just to discuss it. My focus today is only building dashboards or trying to pick the matrix that would help you to manage your capacity. There are metrics to give you, of course, the visibility, and other metrics, to some internal aspects of your system to help you optimize or figure out some behavioral bugs. There are also dashboards for reliability and availability of your system. We're not going to touch all of these today. We're only going to focus today on capacity management, matrix and dashboards. Okay, so let's start with the user experience. So the user experience, as I mentioned, is all about pick what actually represent the quality of your application, or they represent what the main job of your application. And since we're talking about backend systems, mainly here, or cloud-based systems, it's all about, or you can easily, boil it down into an API or a few API calls. So you need to pick a few API calls and basically say, this is my KPI, is to achieve this certain latency, this certain throughput, how many calls per minute or per second, and of course, the error rate that you would like to make sure that you do not exceed. So this is basically the first step. Pick 1 or 2 APIs, set the KPIs for those. What is the average latency? What is the throughput? And what is the error rate that you would like to basically make sure that you're under all the time. Now, one common thing that I see most of the time, especially in large-scale systems, that they pick the KPI and they assume that users are uniform in their requests and the results are going to be uniform as well, the returned results. And as a result of this, they basically get a lot of noisy matrix. I'll give you an example. So let's say there's an API that just gets a couple of parameters to return a list of items, a search API. And that search API, the results of that it can return vary a lot by the search criteria or some of the terms that you have. Maybe you need to scan multiple tables versus one table and so on. So if you actually if you are considering having only that API as just a single kind of category by itself, you're gonna end up with distorted results. You're not gonna have results that you can really depend on, because you're gonna have a few users are having simple search calls that's gonna, let's say, return maybe a few kilobytes worth of data. And then some others, we're gonna have extensive search queries that would maybe return megabytes of data. And in that case, you should not consider that API as a single API call and just measure it all together. You should break it down maybe into category 1, 2, and 3, and set the KPI for each one of these. If I have a very simplified search, what would be my KPI? If I have a complex search, what would be my KPI? And then from there, you can definitely consider each one of them with its own kind of dashboards and matrix and so on. So the whole idea is also to, behind drilling or getting into the KPIs, is also to use the right statistical method. One of the very common mistakes in smaller companies or with teams that are getting started with having dashboards and trying to be really more diligent about how they monitor their services, is that they use averages all the time. What is the average latency? What is the average throughput and so on? This does not work. Using the average is going definitely to lose a lot of precision, and it's going to basically make the picture very, very blurry for you. So my recommendation is basically to use percentile for almost all your metrics, especially anything that would monitor the latency and throughput. Of course, the 50 percentile, 90 percentile, 95 percentile, and so on, and start with a relatively low number, and then increase your KPI goals. Now, another thing that's also important to consider here, and this is also another common mistake that I see, that I see DevOps or folks who are after building dashboards and matrix, they treat all their APIs equally. Some APIs are important for your business, some or KPIs are important. Some of them could come secondary in general. And this actually means that that you do not have to boil the ocean from the beginning. You need just to focus on very specific KPIs. I'll give you an example. Would you consider the login and the registration for your application as a tier 1 API that is really, really important for you? Or let's say a search API that maybe use 20% of the time. Which one of these you really want to optimize for? Or you want to have a strong KPI that you have to optimize for and make sure that you have the right capacity allocated for its corresponding microservices. And obviously the login and the registration is important because it's pretty much like the entry to your store, to your application. So you want to make sure that they're prioritized, or tier 1 or tier 0 APIs with very strict kind of performance requirements. All right, cool. So this is just generally about selecting the KPIs. The next step is relatively simple as well. It's basically mapping those KPIs to microservices. In the microservices world, a single API can be easily mapped to 2 or 3 or 4 microservices in the back end. Even as simple as login. Sometimes you need to consult multiple microservices in the back. So having that mapping is really important. And now it's relatively easy to do that, even if you do not have any prior knowledge about the system. Istio and other systems within this family can actually help you to draw a really nice graph of your APIs and how they're broken down into different microservices API calls. And from there, what you need to do is, okay, what is my service level objective? because you cannot really achieve your KPI without understanding what is going on. So you're basically just getting it to the next level of details. And then from that point, you basically build a dashboard that shows the KPI and all the corresponding microservices SLOs. And what you want to do is basically find the correlation between those patterns. So if you take a look at the at the snapshots here, you'll notice that the KPI that we have here at the top has its own pattern, and it's roughly actually close. The microservices that satisfy the requests of that user level API, they're roughly following the same pattern. But there's some anomalies here, like here, here. They're not really matching what we see with that KPI. And what we would like to do is, okay, understand why is that? Did we have a certain API call here that really caused one of the microservices to spike or not? Understanding those patterns are really important, because at the end of the day, okay, this microservice at that particular spike in my latency, did it really have a resources stress or not? Did it have, let's say, a CPU throttling, or did it have any network kind of congestions that caused that microservice to have a high latency? And of course, drilling down into those particular APIs or specific APIs that took place at that time would allow you to figure out whether maybe a particular pattern that took place that caused that. But that mapping is your next step. And now that the third step is relatively also simple, but very critical, and I see a lot of teams really miss that, which is, okay, I have now my SLO or my mapping, and I want to know how is that impacting my use of resources. When I got that spike that I mentioned last time, is that because of a stress that had took place on my CPU? Was it because of the network? Or maybe was it because of just a noisy neighbor that was running at the same time beside that container or beside that microservice? Considering all of these is very important. Just having those charts lined up in a single dashboard might be an eye-opener for you to show you whether there is some sort of a pattern or not. But in a nutshell, what you would like to have is CPU, memory, network, storage, the reads and writes rates. Those are the things that you would like to have for a single microservice or pod or a container. And then what you would like to do is basically just focus on the right measurements and of those resources, and they're relatively simple. As I said, use the percentile for compressible resources like CPU, network, read write from the storage, devices in general, especially if they're network attached. And of course, for memory, because memory is really sensitive and it's not a compressible resource, you need to make sure that you're measuring the max, not the average. You want to make sure what is the max that my container or pod was consuming at any given point. Cool. There's actually a webinar, an upcoming webinar on September 17th, where we're going to drill deeper into those metrics and how each one of those metrics is going to impact the performance of your pod and container, and the differences between the Kubernetes scheduler and Linux scheduler, and how those sometimes conflict with each other. So stay tuned or register for that webinar. It's just a week away from today, and you're going to learn a lot about the specifics of the matrix. Today, we're just trying to provide a high-level framework for matrix and dashboards to connect them to resources. All right, then that last step, which is an interesting step and an important step at the same time, which is characterizing your resources usage, the patterns. You want to quantify, what kind of resources that each microservice or pod tend to use more. And from that, it's going to help you to map the right pods and containers to right node sizes or node types in your Kubernetes. And of course, it's going to impact a lot of things related to how you manage your own VMs capacity, how you allocate them, and how you provide annotations and hints to the scheduler to push the right the containers with the right tendency to the right VMs. And that's actually going to be the topic of my next webinar of this series. Today, we're going to just focus on how to characterize those resources. So the whole idea is basically to figure out whether your microservice is CPU, memory, network, or IO in general intensive. And then from that point, you want to figure out some future planning hints. So if you're network intensive, you don't want to allocate your pod to a VM that is actually CPU intensive, because its network performance most likely is not going to meet your needs, or is going to be just too expensive for you to accommodate. And I'm going to get into that in a bit. So the first thing that you want to do is to decide on the balance. What does a balanced microservice means? If I have a microservice that is using one CPU core, 2 gigabytes of memory, and 10 gigabits of network, for example, do I consider this a balanced microservice or not? Now, that number is arbitrary. It depends on your infrastructure. Just a quick hint for you to calculate that, to basically just get the baseline that you're going to compare your microservices against. You can actually use the provider's general VM ratio that you have right now. I'll give you an example, and actually is shown here in that chart. In AWS world, the M6 is the general instance. And if you take a look at the M6 configurations, M6 actually, for each one CPU core, there's a 4 gigabyte of memory and around 5 gigabits of network traffic, or network bandwidth, I mean, that is available with that ratio. So if I have a microservice that is using only one core, but it's using 16 gigabytes of memory for that one core needs from a CPU perspective, and if I place it on that M6 machine, it's not going to be the best fit. Take a look here, actually, in that chart. That microservice, the example that we have here, is telling me that this microservice has a tendency to use memory a lot. And the white rectangle here, the right triangle here is basically showing me that, well, the M6 machine has a lot of network bandwidth, has a decent CPU, and a decent memory capacity. If I place my microservice on top of it, then I would have to, there's a big gap here. I would have to basically book a really large machine, let's say 2XL, to accommodate that microservice. But if I just make a simple change, just the same instance size, but a different type. Let's say I select the R5 instance. Oops. Now I'm closer to the memory needs. I'm gonna need, rather than needing or allocating an R6, let's say 2x large, or M6 2x large, I'm gonna need R6 or R5 large, or 1x large. And the reason is because that microservice has that tendency to be memory intensive, or to use memory more than the CPU itself. So at the end of the day, to do that, you need just to do 2 steps. Pick a baseline to decide what is your baseline in general. And then based on that, compare your microservices tendency to use a specific resource more than others. And it just by doing a very simple calculation of ratio between how much CPU it uses and that baseline, and the memory and that baseline, and so on. And from that, you can know whether your microservice is a CPU, memory, or IO intensive. And that, at the end of the day, will allow you to allocate that microservice to the right instance. This is very, very important because this is the very common mistake. This is the most common mistake actually that I see with many teams, which is, okay, let me just get a gigantic general machine or VM like the M6 or M5 machine types in the case of AWS, and just throw my microservices on top of them. Yes, those VMs are going to perform well for your microservices, but you're throwing a lot of money on the ground. You're basically allocating a very large machine to get the memory, but the CPU is not really utilized. Or maybe the other way around. You're allocating that machine or provisioning that machine to get most of its CPU, but you're throwing the memory on the ground because you picked the wrong machine type. And that comes from not really just able to see how much on average the CPU, the microservice is using each resource versus the others. So this is very, very important. All right, cool. Just to recap, 4 main steps. User experience and KPIs. You want to make sure that you're selecting the right ones that really represent your business or the core of your application. And then map this to microservices, break it down. It's pretty much like profiling an API, but what we're trying to do is you're basically just mapping the pattern from that higher level KPI to the next level, which is the microservices SLOs. And then map those API calls or those usage patterns or workloads to resources usage. And we mentioned that you need to monitor CPU, memory, and network, and use the right statistical methods. And then the last step, which is really important for you to allocate the right pods to the right node pools when that step comes or kicks in into that whole framework by understanding whether those microservices have certain tendencies in your general use of resources. All right, common mistakes. So the common mistakes that I've seen so far in following, that general framework, that you try to implement everything from day one. That this is not possible. Even though I mentioned it really quickly, it didn't take me more than 15 minutes or 20 minutes to go through that whole framework. It's easier said than done. It requires, number one, for the team to be on the same page. They understand that mapping. Number two, you want to make sure that you have the right measures in place and you understand the differences between different statistical methods to measure those metrics. And of course, building the dashboards themselves. So my recommendation is start simple. Just pick one KPI, map it to whatever it maps to inside your system, and just have it end to end and repeat from that point multiple times until you basically cover all your KPIs and cover all your microservices. And then the other second most common mistake that I see is that DevOps or developers are not really opinionated about their dashboards. Or in other words, they do not have a clear framework in mind about what kind of dashboards they need to build and what kind of data those dashboards need to reveal to them. You cannot really just build a single dashboard that will tell you everything. The dashboard at the end of the day must have a single main goal that it will basically, it should do, satisfy that goal in the best possible way. So if you're building a dashboard for your capacity management, you have to have some certain, thoughts and ideas and a framework in mind to do that mapping all the way from the user experience to the resources, utilization and usage. You cannot, just have a bunch of matrix, throw them there without really having, a clear plan in mind on how you're going to manage your capacity, how you're going to take it from the high level goals all the way to the lowest level of resources usage. And of course, not using the right statistical method is the third most common mistake that I've seen also. A lot of the time, I'm guilty also of making that mistake. At a certain point, we're just using average. And the average basically does not help. The average just basically make your measurements not accurate, the least that I can say about that. And it's going to mislead you and mislead your team as well on when and how to optimize. I have a story actually around that. I remember the first few weeks in my job at Climate, I took a look at the dashboards, and I was telling them, look, guys, the average CPU utilization is 5%. Why are we allocating those gigantic machines? And I was about to, just turn off those machines or re-provision them with the smaller sizes, until one of our C engineers, stopped me and he said, look, yes, this is what you see in terms of the average, but we get spikes. We get at certain times of the day, and they're very short spikes. And because we're using the average, we're not seeing those spikes. Do not really do that, but do not really deprovision those machines. When we selected the right statistical methods, like the 50, 60, 90 percentile, and so on, and also tracking the max and the min and the standard deviation between those, we realized, yes, that there is those are actually, those sizes are needed. Otherwise, we're going to have a big performance issue during those times of the day. That was before us implementing Kubernetes. Still, the way that they were at that time, even after having the right visibility, they were not efficient, and we improved them. But we were about to make a very dangerous decision, and a wrong decision, of course, just because we were using the averages. We're not using the right statistical measures as we go through our matrix and dashboards. All right, cool. So a quick thing, we have teams and we have companies to optimize their capacity for Kubernetes specifically. Feel free to book a meeting with us. We're happy to walk with you through your dashboards and matrix and see if there are any certain improvements that can be done to help you think in the right way about the how to manage your capacity on top of Kubernetes. What I mentioned today is quite generic. It doesn't have to be only for Kubernetes, but we're doing what we're doing today because we're going to take those outcomes or outputs to use them in our next step. And the next step is basically doing the right budgeting, selecting the right node pools, and giving hints through annotations and labels and selectors to the Kubernetes scheduler to send the pods to the right VMs. So feel free to schedule a meeting with us. We're happy to walk through your dashboards or how you do your capacity management right now and help you out. The next webinar is basically, as I mentioned, is how to set the right limits and requests for your pods and containers, and how to adjust the capacity is what is going to come after that. In that next webinar, I'll be covering 5 main points, which is, what kind of matrix for CPU and memory that you need to monitor before you can set the limits and requests. And that topic is a tricky topic. A lot of companies and teams overlook that part. We also made those mistakes ourselves, so it's worth sharing our experience. We're going to go through the different types of resources starvation and waste within your Kubernetes. A lot of teams set the requests and limits the wrong ways, and that results of either starvation for some of your pods in CPU or maybe memory, or of course a lot of waste, which is even the most common or more common than the starvation part. How can you avoid optimization fatigue, which is something that we also see in some teams. They became obsessed about saving money and improving performance, and they feel really tired after a few trials. And best way to drive a good resource and capacity budgeting when you use the HPA and VPA, and how to build a continuous improvement culture in general to make sure that your resources allocation is done right. Cool. With that, that actually concludes our webinar for today. I'm all ears for questions or comments, and we're happy to walk you through, guys, any specific steps in more detail if needed.
Cool. Thanks, Mohammed. If anyone has a question, you can just talking has been turned on for everybody. So just go ahead and chime in. And if not, we can wrap up early. Our one non-Magalixer jumped off, so I think we can call it here then.